road and street corridors serve our nation's transportation needs and also provide space for public utilities. This sharing of a common right-of-way has helped to bring efficient, reliable, and economic utility service to all Americans. However, each year, as a result of vehicles colliding with some of the 80 million utility poles located within the road and street right-of-way, about 1,500 people are killed and another 65,000 are injured. In addition, these collisions represent a substantial cost to the utility industry in terms of damaged facilities and disrupted service. Can we do something to reduce this terrible toll? The answer is yes. Several countermeasures are available to help reduce the hazards of vehicles hitting utility poles. For example, a utility line might be placed underground, or poles might be located farther away from the edge of the roadway. In some instances, a utility pole might be shielded from impact by placing it behind guardrail, or by placing a crash cushion in front of it. Another countermeasure which might be appropriate in some situations would be to design the utility pole to break away or yield upon impact, so a vehicle would not be stopped abruptly by the pole. This would help reduce the chances of serious injury or death to occupants of the vehicle. The Federal Highway Administration has sponsored research to develop an economical breakaway timber utility pole which would satisfy industry pole design criteria. The latest breakaway design, developed by the Texas Transportation Institute, was successfully crash-tested with both small and large passenger vehicles for a wide range of impact speeds. Under test conditions, serious injury or death to vehicle occupants were judged to be unlikely. The breakaway design, as graphically depicted here and exaggerated for emphasis, has three key components: a slip-base connection, an upper hinge mechanism, and upper support wires. The first component is a slip-base connection. It works on the same principle as the slip-base connections used for luminaire and large highway sign supports. When struck by a vehicle, the bolts holding the two base plates together will either shear or pop out, and the base of the pole will begin to slip or yield. The second component is an upper hinge mechanism placed on the pole about 14 feet above the ground. The pole is cut through at this point, and a metal band and strap connection is placed across the cut. When the bottom of the pole is struck, this upper connection acts like a hinge and allows the lower part of the pole to swing up and away from the impacting vehicle. The third component consists of two steel wire support cables, one attached to the pole just above the upper hinge mechanism and the other just below the crossarm. These cables run from the breakaway pole to an adjacent pole in each direction along the utility line. These support cables help hold the upper part of the pole in place during a vehicle impact. This enables the upper hinge mechanism to work. Once a breakaway device has been successfully crash tested, the next step in the development process is to evaluate the device under actual field conditions. The Kentucky Utilities Company, in cooperation with the Kentucky Transportation Cabinet and the University of Kentucky, has installed breakaway hardware on several existing timber poles in Lexington, Kentucky. Let's look at what was involved in a typical installation. The equipment used for the installation consisted of a digger derrick truck and a double bucket truck. The only special tool not normally used by the crew was a torque wrench. A 5-man crew, which included a supervisor, made the installation. The first step was to establish traffic control at the site. Trucks and equipment encroached upon the curb lane, which, as shown in this typical application, was closed to traffic by the use of a flashing arrow board, traffic cones, and an advance warning sign. The next step was to place the slip-base connection at the bottom of the pole. The boom arm of the digger derrick truck was attached to the upper part of the pole to stabilize it, while the bottom was modified. Next, soil was removed from around the base of the pole. This provided room for making the cut through the pole and space for fitting the lower half of the slip-base assembly over the timber stub remaining in the ground. Using a chainsaw, a cut was made through the pole. The cut is close to the ground, so that the bottom half of the slip base assembly will protrude no more than 4 inches above the surrounding ground. This is done to minimize the chance of snagging the undercarriage of a vehicle passing over the stub. Notches were also cut into the stub to provide room for the bonding material. The lower half of the steel slip base assembly was then placed on the stub. The bonding material was then mixed. It is a 2-component material which is blended at the site. Only enough is mixed to cover immediate needs, since the material sets within a few minutes. The bonding material was poured through a hole in the center of the slip base. As it sets, it expands and fills and seals the area between the timber stub and the slip base assembly. Next, the upper half of the slip base assembly was placed on the above-ground portion of the timber pole, which was temporarily held a few feet to the side. The upper half of the slip base was then positioned over the bottom half. Note that a 1/64 of an inch thick keeper plate is placed between the upper and lower parts of the slip base. This keeper plate prevents the top half from later walking off the bottom half should the bolts loosen with time. The 2 parts of the slip base assembly were fastened together using 6 1 1/8 inch diameter bolts. Adjustment bolts were adjusted to center the pole. Additional filler material was mixed and poured between the timber pole and the upper slip base assembly. Tape was placed temporarily around the top of the steel slip base assembly to ease cleanup of filler material which might spill over the side. Excess amounts were trimmed. The slip base assembly is complete, except for final tightening of the 6 slip base bolts, which will be done later. With the slip base connection placed at the bottom of the pole, the next step was to install steel wire support cables. One was fastened to the pole above the point where the upper hinge mechanism would be placed. The other was attached just below the cross arms. These support wires run from the pole being modified to the next adjacent poles. They were fastened to the poles with a thimble eye bolt and nut and preformed guy grips. Next, the hinge mechanism was installed on the upper part of the pole. 4 1-inch diameter holes were drilled through the pole in the area where 2 steel collars were to be mounted. Then, using a chainsaw, a cut was made through the pole. The collar assemblies, which had been partially assembled on the ground, were then slipped over the 2 ends and bolted in place. The ends were treated with wood preservative and aligned, and the 4 steel straps connecting the collars were placed with the bolts tightened to a torque of 100 foot-pounds with a torque wrench. To complete the installation of the 3 breakaway components, the torque wrench was used to tighten the slip base bolts at the base of the pole to a torque of 200 foot-pounds. It is very important that these bolts not be over or under tightened, as this could affect the performance of the breakaway design. The soil was regraded around the base of the pole, and the traffic control devices were removed. Tim Tucker, Supervisor A for the Kentucky Utilities Company crew, summed up his thoughts on the installation process as follows.
When we installed these breakaway poles, we used a 5-man crew, and it's 1 foreman and 4 linemen. It went quite easily with that amount of people. The length of time we took us depended on the area we were in. Some places we had tree limbs to contend with. Some places we had a lot of wire and it was hard to pick up the pole after we cut it. Cutting the poles is no problem. Putting the hardware on is really no problem, although you do need someone that can drill a couple of real straight holes for the upper bracket. The main problem we had on the lower section was probably putting the bolts in, lining up the little skid plate and putting the bolts in, and then trying to hold the pole at the same time. Overall, it took us about a day to do it, and that's counting travel time and lunch time. Under normal conditions, it'd take about 8 hours.
Hi, I'm Jim Carney, Chief of Federal Highway Administration's Railroads, Utilities, and Programs Branch. It is common practice for utilities to use public road rights-of-way. This has proved a practical and economical means of providing utility services to all of us. It is clearly in the public interest, provided it can be done safely. Unfortunately, this is not always the case. For example, in fatal auto accidents, utility poles are second only to trees as the most frequently hit roadside obstacle. The number and severity of utility pole accidents must be reduced. The costs are simply too high in terms of death and injuries and damage to utility facilities. Fortunately, there are things we can do to reduce this toll. Sober and prudent driving by all would be a big help. Also, we can make our roadsides more kinder and gentler to errant vehicles. You've just seen one possible solution, the breakaway utility pole. However, I want to make it clear that the breakaway utility pole will not solve all utility pole problems by itself. It is but one tool among several that can be used to reduce utility pole hazards. Actually, the preferred solution is to relocate the utility pole facilities out of harm's way. Undergrounding is one means. Placing utility poles as far from the travelway as possible is another. Shielding poles by placing poles behind guardrails or installing crash cushions in front of certain exposed poles may be a practical solution in some cases. In other situations, the breakaway pole may be the thing to do. We know that the device you have seen in this video will work. It will break away. However, its use is limited, and it may not work with all types of poles and configurations. It may not be appropriate for use where pedestrians are common. Nevertheless, we strongly believe that there are many poles which would benefit from this breakaway treatment. What is really needed now is more field testing. We need more experience on its installation and performance. Thanks to the efforts of the Kentucky Transportation Cabinet, the University of Kentucky, and the Kentucky Utilities Company, a number of poles have been retrofitted. What we have learned to date from this experience has been very encouraging. We are hopeful that additional poles will shortly be installed and evaluated in Massachusetts. We would like to install many more of these devices. Existing poles can be retrofitted in place, or devices placed on poles before they are placed in the ground. We would welcome as many installations as possible under a wide range of real-world conditions. The installing of breakaway devices on exposed utility poles is eligible for funding under the Federal Aid Highway Program. For example, these devices could be experimental, using Federal Aid Highway construction funds. We know that the designs tested to date are limited. Therefore, we must look to and strongly encourage more development by the utility industry of breakaway devices to address other designs and configurations. There's always a better way to do things if we but look. I do not want to minimize the problems involved in roadside improvement programs. Budgeting for improvements must compete with several other essential expenditures. Identification of accident sites or potential sites can be very difficult. There never seems to be enough right-of-way to do all the things we would like to do. Space is limited and in many cases is the main problem. There is no overnight quick fix solution to the utility roadside pole problem. Safe and efficient utility accommodation on our roads and streets is a challenge to both highway and utility officials. However, if we commit ourselves to meeting this challenge, and if we work together, this goal, in time, can reasonably be achieved. It can be done.